ride the grid, and that's the whole game. On the Hubble brain, I don't drive so much as tune. In passive phase, I'm sipping energy, letting the universe do the heavy lifting while my ship surfs the straightened grid at a constant velocity. Then comes the pounce active phase. I pour power into thrusters, field generators to grip the lattice, break the passive lock pivot. Once the new heading bites, I relock and go silent again. Long rides become a heartbeat of bursts hush. Do I risk overshooting the grid if I speed up? Not exactly. The expanse always stretches. I can't outrun space, but I can slip out of sync with the local expansion vector. That desync shows up as drift my wake, slicing across the grid lines. Bleeding efficiency, forcing a costly correction. The art is hitting a climb that's just strong enough to shear the old vector, then easing back before the grid snaps me into a wasteful arc. Navigation is calculus in motion. I don't point at a star. I solve for an intercept between my manual velocity and the grid's rate of change. Coordinates are alive. Distance stretches under me while I move over it. My steering wake is the chisel. The grid is the marble. A flight looks like this. Injection punch out of the planetary dip. Gridlock pause, acceleration, and ride weightless. Course correction short, hot pounce to slide onto a new vector. Re-entry bleed speed, then hand off to gravity. Final approach. I start by braking against the grid, creating a counterweight to kill my drift. As my frame syncs with the destination's geodesic, I let the gravity well catch me. Engines thread the needle. Gravity closes the stitch. Ride the grid. Pounce with purpose. Arrive on a whisper. Albert Einstein put a speed limit on energy in its relationship with space aviation. By doing this, his theory governs physics with relationship with aviation flight. When you observe aspects about Earth aviation, propulsion, and flight, they set in different categories. It is true that Einstein's special relativity established a universal speed limit in the speed of light, c, which fundamentally dictates how energy, mass, and time behave as an object accelerates. In the context of traditional aviation, we rarely encounter these effects because our flight speeds are negligible compared to c. However, as we look toward the future of space exploration, the distinction between aeronautics and astronautics becomes a matter of shifting physics. To understand how these categories differ, it helps to look at the three primary domains of flight. This category relies on the interaction between a vehicle and a fluid medium, air. Propulsion here is about displacing mass, pulling air in and pushing it out faster. Jet engines are using pressure differentials, lift, the physics, Newtonian mechanics, and fluid dynamics. The limit, the sound barrier, and thermal limits caused by atmospheric friction. Einsteinian relativity has no measurable impact here. Once we exit the atmosphere, we move from aerodynamics to astrodynamics. Propulsion is no longer about interacting with the environment, but about conservation of momentum. The physics, Keplerian orbits, and the Tsiolkovsky rocket equation, the limit, fuel-to-mass ratios. To go faster, you need more fuel, but that fuel adds mass, which requires even more fuel. This is the tyranny of the rocket equation. This is where Einstein's speed limit becomes the primary governor. As a spacecraft approaches a significant fraction of light speed, the energy mass equivalence formula comes into play. E is mc2, where g, the Lorentz factor, increases toward infinity as velocity approaches c. The shift in categories. When observing these aspects, the categories diverge based on what the propulsion system is fighting against. Earth aviation fights gravity and drag using lift. Standard spaceflight fights gravity and inertia using chemical or ion expulsion. Theoretical advanced propulsion attempts to bypass Einstein's limit by manipulating space-time itself. Instead of pushing a craft through space, which is governed by the speed limit, theories involving warp or metric engineering suggest moving the space around the craft. In these models, the ship remains stationary within a local bubble of space while the bubble itself moves. This shifts the category from kinetic propulsion to metric engineering, effectively navigating the laws of relativity by changing the geometry of the vacuum. That is a powerful way to frame it. There is a profound alienation between the physics of our everyday world and the extreme scales that Einstein introduced. In many ways, modern aviation is the ultimate monument to Newtonian mechanics, while the future of deep space travel is forced to reckon with the Einsteinian reality. The two feel alienated because they operate in different languages of force and movement.